Jordan, and I'm going to be doing the interactive presentation for week 5, the penny experiment. So what I have here is some salt, some vinegar, a little bit of water or pennies, dirty pennies, and then I have a control penny, sort of like a clean one, just to see. It's in 2021, so a cleaner one just so we can compare it, and then older dirty penny just so we can see how dirty or how much more clean it gets. All right, so let me go ahead and pour my 1/4 cup of vinegar in. Okay. Now we are going to put in 1 teaspoon of salt, as best as we can manage. So here's about a teaspoon of salt. I'm also going to put in what's on the paper towel. So there's just a little bit left over here. Okay. I'm just going to go ahead and give this a little stir. It should dissolve. These are a little bit, of course, salt flakes, so it might take a little bit longer to dissolve. Let me get like a wooden spoon real quick. Here we go. Actually use a plastic spoon. Slowly dissolving. These are pretty coarse. Okay. You can see that the majority of the salt is dissolved, if you can see. I don't know if you can. There you go. All right. So we're gonna go ahead and throw our pennies in. So these pennies are pretty dirty if you just want to see the before and after. So throw a bunch of these in here, sort of separate them out so they can cover it evenly. Some of these are actually pretty nasty. Sort of move it around a little bit. Okay. So we'll just wait here for about 2 minutes or so to see what happens. All right. So basically the gist of this, just to go over what should happen. So most pennies have copper oxide on them, basically a lot of the dirt that's on them already. Basically what happens is when the copper oxide forms with the copper, it's oxidized by its reaction with the oxygen in the air. So it actually dissolves in water, but it takes a while. What we do is we introduce the weak acid, which is the vinegar, the acetic acid, and table salt, the obviously sodium chloride, and it helps to dissolve the copper oxide. It also forms blue copper 2 ion, which actually dissolves in the water, so it's water soluble. So that's why it becomes shiny again. So it's pretty interesting. So these actually are looking pretty clean already, to be honest. It's actually crazy. So in short, copper oxide is reacting with the air to previously make the penny dirty. It's oxidized, and then we're actually causing a chemical reaction with the table salts and the vinegar, and that reaction forms another layer with the oxidation, and that actually dissolves in the water itself. So another thing that happens is that we can stop. So we'll go ahead and take them out. They're pretty clean now. We'll go ahead and take them out. We'll just throw them in the water. The water actually stops the chemical process from happening. Okay, so that's that. I'm gonna give these a little whirl. Clean up our spoon. We sort of agitate it with our spoon. Okay, we'll go ahead and pluck these out. Now that the chemical reaction has stopped, we can sort of compare our control stuff with what we had earlier. Okay, so let's drain them off a little bit. Okay, so these paintings are actually a lot cleaner than before. So if we can see here, so this is about, so this was about a dirty one before. If you can see that, compared to what we have now when we went through our chemical reaction process. A lot cleaner. I'll show you the back. And then compare that to our I wouldn't say new penny, but 2021, it looked pretty clean to me. So I mean, it doesn't really have much on it at all. So this is a new penny control. It didn't go under any reaction. So yeah, so all in all, let me see if I can show you the rest of them. So I don't know if we can see the rest, but some of these, as you can see, are, you know, still pretty dark. I'm assuming this is a different chemical reaction that occurred on these rather than the, you know, the normal oxidation with the copper. I'm assuming this came in contact with something else, which is why our chemical reaction didn't work. So overall, fun little experiment. Thank you.